using a colored pencil, let's color our little diagonals are congruent. So I want you to take your color, whichever color you choose, and we're not gonna do a lot of colors on the rectangle because I feel like a lot of you should already know the sides are congruent to each other. Like the top of this congruent to the bottom, this side is congruent to the other side. Me too. So your diagonals are congruent. So if I knew one of the diagonals was 10, automatically the other one would also be 10. They also bisect each other. So using your pencil, I want you to put little tick marks. This is congruent to this, which is congruent to this, which is congruent to this. So if I know each one of those little tick marks was 5, all the other tick marks would also be 5 to make a total of 10 for your diagonals. Right angles technically mean 90 degrees. So using your pencil, I just wanted you to put equals 90 degrees. And then that's really the only thing we're going to color on this diagram paper, but we are going to use the colors on the actual worksheet because we're going to have to use different theorems to solve for things. Okay, so keep the colors out. Somebody was really upset earlier that we weren't adding more colors to the rectangle. They were like, I like the colors. Yes. So we could color the top matches the bottom and the sides match the sides, but you should know that, hopefully. So I don't want to just color things so that way we're coloring things. I want like you to color things that are new. Okay, so on today's paper, let's label this number 81 at the top. Put your name on it. It is class period 5. Today's date is 2/12. Okay, so our new things that we're going to add to our rectangles is everything from the parallelograms, but also we have 4 right angles. And now the diagonals bisect each other. Now the diagonals are also congruent. So we have congruent diagonals. So let's start with numero dos. So let's just look at our numbers and move around what we can and then see if they give us enough information to answer every single problem. So where else can the 27 go? A to B, because that makes sense. Okay, where else can 15 go? EC. And where else? And where else? And ED. So each one of those little pieces is 15 in length. People get it confused with like degrees. Degrees would have the little bubble. Okay. This is not a little bubble. This is a length. So let's see if we have everything we need. So what's A to C? 30, because it's all the way across. So 15 plus 15 is 30. What about BD? 30. What about BE? 15. What about AB? 27. And then do we have a number at BC? No. How am I going to find that guy? My God, you're a genius. We're going to make a right triangle and we're going to use the Pythagorean theorem. So each corner, even though it's not on there, has a right angle. So what is the base length of this triangle? What is it? So I don't know this. What's going to be the base of the right triangle? Nope. It's not 15. 27, because we're making a right triangle, so it needs to be perpendicular. And then I'm cutting across. The diagonal is going to be the C. So we're going to make the Pythagorean theorem, and then we're going to solve for BC. So if I have a little right triangle, I have 27 down here. The diagonal's 30. Am I trying to find A, B, or C? A or B. So I'll just call it B. Okay, so we're going to do 27 squared plus B squared equals 30 squared. Yes. So what's 27 to the power 2? So this is one of those weirdos that you're going to have to minus to both sides because you know C. So if I subtract 729 from 900, what do you get? And then when you square root it, you get 13.1. Nice. Easy peasy. Try number 1. Easy peasy. Number 1. Numero uno. Numero uno. No, they're not all decimals. I think this one comes out to be a nice. Okay. We need another second. Take another shot. I'll drink my coffee. Okay. So what's QR? 10. What's SR? 24. What's SQ? So this is the one that, wait, what'd you get? Okay, wait a minute. SQ, we're doing S to Q, we're doing 10 squared plus 24 squared. 10 squared is 100. What's 24 squared? 576. If you add them together, you get 676. And then you have to square root 676. So what do you get? 26. Oh, okay. I thought I heard a bunch of craziness. Okay, so SQ is 26. That's the diagonal all the way across. So what's P to R? 26. And then what's half of your diagonal? 13. Because you're cutting it in half. The whole thing's 26. That piece, because this splits it into 2, makes 13 and 13. Okay, so side length. When you have 90 degrees, you're going to use Pythagorean theorem to find missing side lengths. We're going to now do angles. This is where people get confused with the angles. I think angles make more sense today than it did yesterday with parallelograms because I don't know why. Maybe it's just clicking finally. So for number 3, you get one number. We have to fill in every other spot. So there's one place 27 can go. Where else can 27 go? L down at the bottom, because remember, it jumps across the transversal. Now, how do I find what's next to 27? Not 180, 90, because each corner represents a right angle, which is 90 degrees. So if this is 27, 27 plus what makes 90 if you subtract them? What is it? 63. 63 can then also jump across, right? 63 can also go here. Now, this is the weird thing is technically you have a bunch of triangles inside this rectangle because it's being split up by the diagonals. So technically, if I cover this up And if I cover this up, I have just like one little triangle that I'm focused on, okay? Technically, the diagonals have congruent pieces. So this is congruent and this is congruent, right? Because they're bisecting and now they're congruent. So this is technically, does anybody remember what kind of triangle it is if it has two congruent sides? Isosceles. Isosceles triangles have a nice little trick. If the sides are congruent, then the base angles are also congruent. So if this is 27 degrees can't go at the top, but it can go at the other base angle. So 27 can go here because they match because the sides are congruent. So using that same method, I can jump across and put 27 up here, which means what's going to be in all the other little angles? Good, because you also technically have isosceles triangles over here. You also have isosceles triangle, isosceles triangle, isosceles triangle. Now we have to find all the angles where n is. So somebody with a big brain, how could I figure out, I don't know, let's talk about this one right here. How could I find that angle right there next to n? Yes, because technically it's just a cute little baby triangle, and a triangle still adds to make 180. Okay, so the inside adds to make 180. So if I take 180, I subtract 63, I subtract 63, what do I get for that angle? What is it? 54. And then where else can 54 go? Huh? The other side, because technically vertical angles are congruent from chapter 2, but also you also have that isosceles triangle over there. It's identical, so of course it's going to be 54. Use that same method. You also have an isosceles triangle up at the top. So take 180, you're going to minus 27 and 27 and find that obtuse angle, which should be more than 90 because it's an obtuse angle at the top of that triangle. It's just like flipped upside down. Anybody? $123. And this is what I would say half of this class is bad at, is writing down the angles. By May 20th, you need to know how to read angles. Okay. They use 3 letters. Yes, it does focus on the middle letter J, but J has 3 directions. It's the whole angle as a whole. It also has 63 and 27. Sometimes it's just 27, sometimes it's just 63, or sometimes it's the whole thing. So in this case, if I start at M, I go to J, and I end at K, how much total is that going to be? Is it 126? It is 126. Oh my God, it is 126. Nobody even said anything. Lena, you get extra credit. Thanks. Why am I grabbing my calendar? Not the calendar. I need the sticky note. Thank you. Yeah, it's 126. My bad. Okay, so how much is MJK as a whole? 90 degrees. The next one says MJL. 63 because it's a piece of it. Take a second, see if you can fill out the last 3 angles. So MJL cuts across, so it's talking about this pink corner. MJK was the whole thing. MJL is this piece. So try the last 3, see if you can figure it out. You might be able to do the entire math problem on the ESC, but if you can't read an angle and figure out which one they're asking for, then like you're screwed. So what's JLK? 63. Nice. Okay. What's what's KML? 27. And then MNL? 126, not 123. Okay. Try number 4. There's only one number. You got to move it around. There's one place it can go to. And then you have to think triangles make 180. The base angles are congruent to the triangles because it's an isosceles triangle. So you can move the 64 to one place. The base angles to your triangle have to be the same number. They have to be congruent. Once you figure out that those angles, everything else should flow. Has anybody figured out how to find, because this one's a little bit harder. Has anybody figured out what to do? Perfect. So if you take the one angle out that you have, you get 116, and then you have to divide by 2. So if you were stuck, you got to divide by 2 because that makes each angle 58 degrees. Once you have 58 degrees, you should be able to work around and figure out everything else because 58 plus something needs to make 90 in each corner. So take another minute, try to figure out the rest. But then try to fill in all your answers too with your 3 letters. Okay, so you should have got 32 here, 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 and here. What's the last angle inside the triangle? 116. What's up? Yes. Just bring me your phone. Okay, so what is XWY? Huh? 58. Nice. Okay, what's YX to Z? YXZ 32. What about WV? Where's V? WVZ 116. Good. Okay, then we have XWZ 90. And then XZY 58. Okay, let's go to the back. We're going to set up 2 problems and then you guys can just start working on this. So I think the angles are hard. The back is easier. The back is like setting things equal to each other or adding to make something. For number 12, let's look at what we got. Do these equal to each other? No, they don't. Because we would have to jump across the transversal, okay, for them to be equal. So I could move them. So I could put 5x minus 8 here. And I could put x plus 20 here because they jump across the transversal like parallel lines, alternate interior angles. Okay. I don't need to use both corners. What could I do with one of these corners to solve for x? They don't equal to each other. It's not an angle bisector. Add to make what? 90. So we're not adding to make 180. We're going to add to make 90 because one corner makes 90 degrees in total. So we could do 5x minus 8 plus x plus 20 equals a corner, and a corner is 90. So if I combine x's, 5x plus 1x is 6x. If I combine -8 and 20, how much does that make? Not 28, no. 12. Then it's a two-step equation. I can minus and divide. What's 78 divided by 6? 13. And now we got to figure out where we got to plug it back in. So it says find XZW. So XZW, huh? We're looking for Z. We're going to plug it into the 5x because it says XZW. So if you follow it, it's talking about this portion. It's like eating this part. Okay. So we're plugging it into 5x minus 8. So 5 times 13 minus 8 gives me what? What is it? 16. I don't even know. 57. Yeah, that's right. So your answer is 57.